right, so in the last lesson we did, we looked at velocity and acceleration using vector-valued functions, and we ended with a discussion about the projectile motion equation. And that equation you can see here, right at the top there, this R of t equals thing. And basically what you need to know about that equation is that this is your horizontal component. This is like your x component, and this is your vertical component, that's your y component, and you are free to separate them as you see fit, which is honestly what I do like every time. So if we want to look at some of these in context, we can just look at these in terms of horizontal and vertical values and constants and figure out what we need for something to exist. So, first example, the Houston Texans punter Shane Leckler kicks a punt during a game. He has to punt because the Texans are incapable of getting a first down. They're my team. I really like the Texans. I've been with them since they started. But I can be honest, they are not that good. So anyway, because Shane kicks so many punts, he's got a pretty strong leg, and he can kick with a speed of 90 feet per second. He wants the ball to have a hang time of 2.2 seconds. At what angle should he kick the ball? So the values that we need here are given right there. And let's see. It says assume that the kick is caught at the same height from which it's kicked. So that's going to be important. And we're just going to try to plug everything into these two equations, really. We've got an x equation here and a y equation here. We're going to plug things into these equations and kind of see what happens here. And yes, I did look these values up to try to make them as realistic as possible. So our x equation is v sub 0 cosine theta t, and our y equation is h plus v sub 0 sine theta t minus 1/2 gt squared. Technically, I should put that in parentheses to make it clear that the theta and the t aren't being multiplied. So there I have it. Let's see. What angle should he kick the ball? 2.2 seconds. All right, well, let's fill in some stuff. Well, do I know x? Nope, don't know how far it's going down the field, so I'm just going to leave x as x. V sub 0 is the initial speed or velocity with which he kicks the ball, and that's 90 feet per second. What angle is he supposed to kick it at? So cosine theta is unknown. And then t, we want it to have a hang time of 2.2 seconds, so that's going to go there. All right, there's an equation, but it's not solvable, so I'm going to leave it alone for now. Over here, y. Well, y and h stand for the height when it's caught and the height when it's kicked. So this said to just assume that it's caught and kicked at the same height. So I'm just going to call this h0 and h0. And then 90 sine theta times 2.2 minus 1/2 gt squared. This is feet. So gravity is 32 feet per second, and time is 2.2. And let's see, on this one, oh, that was supposed to be plus, not an equals. My apologies there. So there's an equation. I only have one unknown, which is theta. Technically, I don't know h sub 0, but what's going to happen is I'm going to subtract this over and end up with 0 equals 90 sine theta times 2.2 minus 16 times 2.2 squared. And now my only unknown is theta, so I'm going to pull up a calculator here. Now, we're in calculus, and technically when you're in calculus, you really should be in radians. However, we're not actually doing calculus per se right now because we're not taking any derivatives right now. So it is okay to be in degrees, and that's what I'm actually going to put us in right here. So we're in degrees. And I want to solve for theta, so I'm going to have this 16.2.2 come over here. So 16 times 2.2 squared. So 77.44. And then 90 times 2.2, oops, is 198 sine theta. So I'm going to divide and find theta all at once here. I trust that you guys know how to do that. So 77.44 divided by the answer. I'm going to take the inverse sine of that. 23.023. So 23 degrees. We'll just go to the nearest degree. So 23 degrees. Now, down toward the bottom, it says, how far down the field should the punt returner be in order to catch the ball? Well, that just means take this guy and plug him into the x equation. So I'm going to have x equals 90 cosine 23 times 2.2. So 90 cosine answer times 2.2. 182.228. And if you really want to think about it in terms of a football analogy, if I divide that by 3, I have yards. This is a 60.7 yard punt. Not bad. All right, so that's a quick look into how to do these. But with this, I gave you a lot of information, and even though we had two unknowns technically, x and theta, we didn't actually need to do a system to solve it. The next one, we are going to use a system. Now, this is another one where I looked up everything, so everything is here. And I looked it up. I looked up distances. I looked up Comerica Park, everything. So in 2005, Home Run Derby, Comerica Park, Bobby Abreu hit the longest home run of the tournament. His home run was caught by a fan in a seat that was 460 feet away from home plate, 30 feet above the ground. Assuming the ball left Abreu's bat at an angle of 30 degrees and 3 feet above ground level, how fast did he hit the ball? And do you think that that speed is reasonable? All right, well, let's figure it out here. So we have x equals v sub 0 cosine theta t, and y equals h plus v sub 0 sine theta t minus 1/2 gt squared. And this is in feet, so my gravity is going to be 32. If you're ever in meters, you're going to use 9.8. So let's see. The fan was 460 feet away. How fast did he hit it? I don't know. The angle I know, that's the cosine of 30. And I don't know how long it was in the air, so I don't know v or t. Over here, my y value, the fan was 30 feet above ground level. He hit it 3 feet above ground level. Still don't know v sub 0. I know sine is sine of 30. Don't know t, and this is going to be 16t squared. So now I have two equations and two unknowns. So when I have two equations and two unknowns, I'm going to use a system. And the best way to solve a system is probably substitution. So I'm going to solve this for, let's solve it for v sub 0. So v sub 0 is 460 divided by cos 30 times t. And I'm going to sub that in over here. So then I'm going to have 30 equals 3 plus 460 over cos 30t times sine 30t minus 16t squared. And this looks really hairy, but the nice thing about it is I can take these t's and they cancel out. And then sine 30 divided by cosine 30 is really tan 30. And the tangent of 30 is root 3 over 3. So I have 30 equals 3 plus root 3 over 3 minus 16t squared. And this is a very easily solved example. So I have 30, take away 3, take away root 3 over 3. Oops, I forgot to write the times 460 here. That guy. So take away 3, take away 460 root 3 over 3. And I end up with negative 238.58. I'm going to divide by negative 16. And then I'm going to square root it. Raise it to the 0.5 power, square root it. 3.86. So t equals 3.86 seconds. Okay, well, that didn't get me the speed, and that's what I wanted. So I'm going to take this 3.86 and sub it in over here. And what am I going to get? 460 divided by the product of that number and cosine 30. 137.552. 137.552 feet per second. And then it says, knowing a pitcher, oh, that was weird. Knowing, come on, there we go. Knowing a pitcher can throw a ball at a speed of 90 to 100 miles an hour, do you think that the speed is reasonable? Well, to figure that out, I should probably turn this into miles per hour. So 137.552 feet per second. I'm going to do some dimensional analysis here. There are 60 seconds in 1 minute, and there are 60 minutes in 1 hour, and there are 5,280 feet in 1 mile. So minutes, minutes, seconds, seconds, feet, feet. Now I'm going to have miles per hour. So I have that number times 60 divided by 5280. So this times 60 squared divided by 5,280 gets me about 93.7 miles an hour. And that does relatively seem reasonable. He's going to throw the ball, the bat's going to give it a little bit more force. Sure, that seems okay. Now, down at the bottom, it says Chris Berman, the ESPN announcer, said that the ball was estimated to have a distance of 517 feet. That estimate is created, and still is to this day, by using where the ball would have landed if the stands basically were in the way. So it's created using where the ball landed in the stands to figure out where it would have hit the ground had the stands not been in the way of the ball's path. Was Berman's estimate accurate? So basically what it's asking is, when this thing hits the ground, what's our x value? So when y equals 3 plus v sub 0, 137.552, sine theta t minus 16t squared. When this equals 0, let's solve here. And theta was 30. Put the 30 in there. So if I figure out when that equals 0, I'm going to use the calculator to do that. I'm just going to use the quadratic formula here. So to use the quadratic formula, I need to find b. So I'm going to take this and figure out what b is. Store that as b. And then x equals negative b plus or minus the square root of b squared, oops, that's an I, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that gives it a time of 4.34. So 4.34 seconds before it should hit the ground. Now let's go back to our x equation, which was x equals, what was it? v sub 0 cos 30t. So v sub 0, the 137.552, cos 30 times that t, the 4.34. And again, back to the calculator. I have 137.552 cosine 30 times the answer, 517. And there you have it. He was right. So, context-based, not really that bad. Sometimes you have everything you need. Other times you need a system. And if you use a system, best way to go is probably substitution. All right. So, last terrible Minecraft joke. I'm sorry if you're not a Minecrafter or don't know anything about it. You're probably missing these, but that's all right. All right, so last terrible Minecraft joke is, why does Steve have to punch wood with his fists? How would I know? Get it? Would, how, would. I know it's terrible. I'm sorry. All right. See you again soon.